Ever wonder why metastasis is considered as the most lethal process on Earth? Let's break it down in layman's terms. Picture this. You have a bustling city full of life, and then out of nowhere an unruly mob starts to form. This mob, akin to cancer cells, starts to wreak havoc, but it doesn't stop there. It starts sending its members to other peaceful cities, spreading chaos far and wide. This, in essence, is metastasis, the spread of cancer cells from one part of the body to another. Now, if these rogue cells stayed put, the damage would be localized and easier to control. However, it's the movement, the spread, that proves to be the real danger. Just as a single spark can start a forest fire, a few rogue cells can cause damage beyond comprehension. This is why most cancer patients don't succumb to the disease until it has begun to metastasize. It's not the initial tumor that's usually the most lethal, but the secondary tumors that form when cancer cells break away and set up camp in other parts of the body. These secondary tumors, or metastases, are what make cancer such a formidable foe. So why is it so hard to stop cancer once it starts to metastasize? Well, it's because these cells are incredibly sneaky. They can hide from the immune system, change shape to squeeze through tiny blood vessels, and even commandeer normal cells to help them survive and grow. They're like the ultimate villains in the story of our health. But just as every villain has a weakness, so does metastasis. The key lies in finding that weakness and exploiting it before the cells have a chance to spread. It's a race against time, a battle of wits, and the stakes couldn't be higher. So if metastasis is such a lethal process, how can we possibly halt it? Well, stay tuned, because we're about to delve into the world of modified citrus pectin, a potential game changer in the fight against the spread of cancer. Scene script: enter modified citrus pectin, a potential game changer in the fight against metastasis. Modified citrus pectin, or MCP for short, is a unique substance derived from the pith of citrus fruit peels. It's not just any citrus pectin, though. This pectin has been specially modified to enhance its bioavailability, meaning it's more easily absorbed by the body. This modification process involves changing the structure of the pectin so that it's broken down into smaller, more digestible fragments. The result is a compound that's not only easy to absorb, but also has potential health benefits. The origins of MCP are pretty interesting. It's a classic example of us humans learning from nature and harnessing its power for our benefit. The citrus fruits we enjoy, like oranges, lemons, and grapefruits, have a fibrous layer beneath their peels called the pith. This pith contains pectin, a type of fiber that's been used for centuries in cooking and food preservation. It's this natural pectin that forms the base of MCP. Now let's talk about the potential benefits of MCP. In the context of health and wellness, MCP is often hailed for its possible role in supporting cellular health, promoting healthy immune responses, and even detoxification. But the most intriguing potential benefit of MCP, and the reason we're discussing it today, is its potential role in the fight against metastasis. Yes, you heard right. This humble derivative of citrus fruit peels might just hold the key to halting one of the most lethal processes on Earth. But it's important to note that while the potential of MCP is promising, it's not a magic bullet. It's part of a larger puzzle, a piece in the grand scheme of things that is our understanding of health and disease. And like any potential health solution, it's crucial that it's used wisely and in conjunction with other health-promoting practices. But how exactly does modified citrus pectin work against metastasis? Well, that's what we'll explore in the next part of this discussion. So stay tuned. The way MCP works in halting metastasis is truly fascinating. Now let's delve into the science behind how modified citrus pectin, or MCP, works against this lethal process. MCP is a complex carbohydrate derived from the peel and pulp of citrus fruits, but it's not your average fruit extract. It has a unique ability to bind to a protein called galectin-3. Galectin-3 is a bit of a villain in our story. It's often present in high amounts in people with cancer and plays a key role in the metastasis process. This protein enables cancerous cells to clump together, attach to the walls of blood vessels, and then invade new tissues. It's like a passport for cancer cells, helping them travel and settle in new locations within the body. So, how does MCP come into play? Imagine MCP as a secret agent intercepting this villainous protein. MCP has a special affinity for galectin-3. It can bind to this protein, essentially blocking its ability to interact with cancer cells. In simple terms, MCP can stop galectin-3 from giving cancer cells their passport to spread. Now, why is this binding ability so important? Well, by blocking galectin-3, MCP disrupts a crucial step in the metastasis process. It's like removing a link from a chain. The whole process falls apart. Without galectin-3, cancer cells find it harder to clump together, attach to blood vessel walls, and invade new tissues. In a way, MCP acts as a kind of molecular bouncer, preventing cancer cells from entering and setting up shop in new areas of the body. This can potentially slow down or even halt the spread of cancer, making MCP a powerful ally in the fight against this disease. Moreover, MCP's impact doesn't stop at binding to galectin-3. Some studies suggest that it can also stimulate the immune system's natural killer cells. These cells are part of our body's first line of defense against cancer. By enhancing their activity, MCP may help our bodies more effectively combat and destroy cancer cells. But remember, the human body and diseases like cancer are incredibly complex. There's still a lot we don't know, and the exact mechanisms by which MCP works are still being explored. However, the science we do have paints a promising picture of MCP as a potential tool in the fight against metastasis. It's also important to note that while MCP shows potential, it's not a standalone treatment for cancer. It's one piece of the puzzle, and it's most effective when used in conjunction with other therapies under the guidance of a healthcare professional. So MCP's ability to bind to galectin-3 and potentially halt metastasis is impressive, but what does the research say? Well, let's dive into that in the next segment. Stay tuned. In a recent experiment at the University of Michigan Medical Center, rats were injected with 1 million prostrate tumor cells. Normally, metastasis would occur 10 to 12 days after injection, and the rats would die 13 to 15 days after the cancer had affected the lungs and lymph nodes. In this study, the experimental animals received varying concentrations of modified citrus pectin in their drinking water. Some were given no MCP, some received 0.1% MCP, and some received 1.0 MCP. There was a significant reduction in lung cancer in the animals given MCP in their drinking water for 30 days, while 15 or 16 receiving no MCP developed lung cancer in that time period. Only half of those receiving 0.1% MCP developed lung metastases, and only one of the rats receiving 1.0% MCP solution developed lung metastasis. Lymph node metastasis was also significantly reduced. Whereas 55% of the control animals developed lymph node disease, only 13% of those treated with modified citrus pectin did. No toxicity was reported in any of the animals. And the truly promising and fascinating news is this: the cancer-causing compound that MCP destroys in rat prostate cancer cells, galectin-3, is also present in human tissues, including human prostate tumors. In other words, MCP may prove to work exactly the same way in human male prostate tumors as it does in rat prostate tumors. A number of published papers show that MCP not only inhibits the growth and spread of cancer cells, but also augments your body's natural immune response. There's also evidence from tissue culture studies conducted at the Max Planck Institute in Tübingen, Germany, that modified citrus pectin can enhance the activity of the body's own killer cells. Important note: do not confuse MCP with natural citrus pectin, the kind widely available in health food stores. MCP has been tested extensively against natural citrus pectin, and the studies have shown that natural citrus pectin does not have the same immune-boosting, cancer-killing effects. Look online under modified citrus pectin. The recommended amount is 15 grams or 3 rounded teaspoons per day. Don't just buy the cheap stuff, for it may be the same as natural citrus pectin. The research on MCP and its potential anti-metastatic properties is promising. This statement has been echoed by many scientists, researchers, and health experts around the globe. Let's delve into some of the key studies that have been conducted on modified citrus pectin and its potential to halt metastasis. In one such study, conducted by renowned experts, it was observed that MCP inhibited the growth and metastasis of prostate cancer cells. The researchers found that MCP achieved this by altering the structure of the cancer cells, making it difficult for them to spread to other parts of the body. This is a significant breakthrough in the field of oncology, as it presents a potential natural solution to a problem that has confounded medical science for years. In another study, researchers found that MCP could bind to a protein called galectin-3. This protein is often overexpressed in cancer cells and plays a crucial role in promoting cell growth, survival, and metastasis. By binding to galectin-3, MCP effectively neutralizes its harmful effects, thereby inhibiting the spread of cancer. Furthermore, a study published in the Journal of the National Cancer Institute highlighted MCP's role in preventing breast cancer metastasis. The study found that MCP blocked the cancer cell's ability to attach to the inner walls of blood vessels, a critical step in the metastatic process. These studies, among others, demonstrate the potential of MCP as a powerful tool in the fight against cancer. However, it's important to remember that research is ongoing and more studies are needed to fully understand MCP's mechanisms and effectiveness. So what does this mean for the future of cancer treatment? It means that we may have a powerful, natural weapon in our arsenal that could potentially save millions of lives. It means that MCP could be a game changer, offering a new approach to treating one of the most challenging aspects of cancer, metastasis. So, modified citrus pectin may offer a ray of hope in the grim face of metastasis. And with continued research and exploration, we may soon be able to turn that ray of hope into a beacon of victory against cancer. The fight against metastasis is a tough one, but not impossible. Over the course of this video, we've delved deep into the labyrinth of this lethal process and found a glimmer of hope in modified citrus pectin, or MCP. This naturally derived substance has shown promising potential in halting the spread of cancerous cells throughout the body. We've explored the science behind MCP and how it works to disrupt the metastatic process. We've also discussed the substantial body of evidence supporting its anti-metastatic properties. But remember, while this information is enlightening, it's paramount to conduct your own research and speak with health professionals to understand how MCP could fit into your personal health journey. The complexity of the human body and the fight against diseases like cancer is vast, and it's through continued learning and understanding that we can begin to turn the tide. Remember, in the fight against metastasis, knowledge is power. Stay informed, stay healthy.